Hello guys, so today we'll be doing LeetCode question 94, which is a binary tree in-order traversal. The question is, given the root of a binary tree, return the in-order traversal of its node values. So in-order pretty much means left to right. So you search the left subtree first, go as far left as possible, then you get then you get the center root, we go to the right as soon as all left is complete. So let's go here. Example 1, the root is 1 with a right node of 2, which has a left node of 3. So the output is 1, 3, and 2, because we go as far right as possible. We go as far left as possible, sorry, there's nothing. So we go to center, 1. We go to 2. We go left as possible, 3. Okay. There's no nodes, then we get 3. We go back up, 2. There's no right value, so it ends there. Example 2, we have a root of 1 with a child nodes of 2 and 3. 2 has child nodes of 4 and 5. 3 has child nodes of no left child node and a right child node of 8. Then 4 has no child nodes. 5 has child nodes of 6 and 7, and 8 has a left child node of 9. So the output will be 4, 2, 6, 5, 7, 1, 3, 9, 8. Because again, we get the center value, go left again. 4 is as far left as we go. I'm going further left, set center value 2, then go right. We can go left again, so we go left, take 6. Can't go any further down, so we go up, we get 5. Now we can go right, 7. Go all the way back up. Now we get the center value 1. We go right, because we can't go left, we've already gone left, take 3. We go right, we go left again, take 9. And we can't go any further left or right, so we take 8. And that's the result. So let me show you an example here. So let me show you how to do this. So let's say we have a root of 1. A tree of 1. Let's go 2, 3, it was 4, 5, 6. Let's go use up. Go here, 6. Then I believe it was 7 here. Then 8, and then 9. Okay. So as it's an in-order traversal, we would have to again start from the we'd have to use recursion. So pretty much create a function, and we loop through all the left values until it's null, and then we return the root when there's no left value, and then we go right when there's no right value, we return the root of that as well. So let me show you an example here. We have the array here. Oh, wait, let's make it bigger. Array at the top. Oh. Let's move this. Oh, okay. Array here. Oh my screen. Array. Yeah. Oh, we store the values. So we start at the head, which is 1 here. Then we check if there's a left value. There is. And we check if there's another left value. There is again. So we get to this root. We check if there's another left value. No. We return null here. So we go back up to 4. And then we input that into the array 4. Now check if there's a right value, no, so we go back up. Now we've completed the left side. We turn we turn the root, so 2. We go to the right. We're at 5 now. From 5, check if there's a left value. There's a left value 6. From 6, check if there's a left value. There's no left value. So we input the root, turn 6. If there's a right value, no. We go back up to 5. Now we input number 5, which is the root value. And from 5, we go to the right. Does 7 have a left value? No. We return null. Right value? No. We return null. So we at 7. Now back at 2, 1. So we've searched the whole left side of 1. So now we input the current root, which is 1. Now we go to the right. Now we're on 3. Does 3 have a left value? No. We return null. Then we push 3 to the array. We go right. Now we're at 8. Does 8 have a left value? Yes. 9. Does 9 have a left value? No. So we push 9. Then we go to right of 9, nothing. We go back up to 8. There is no right value on 8 anyway, so we return 8. Then we go back up to 3, and back up to 1. That's the whole tree completed, and this is the result. So we go again, left, center, right, like this. Let me show you the code. So first we create an array, an empty array. Then create a function to do a depth first search. So we do in order. See a question here. We pass the root value as a parameter. Then remember, if there is no root, we return null. So we'll stop looping through the function. It breaks the function as we're going to use recursion. Oh, sorry, I forgot to put return null. And then we first loop through the left value of the root. Then, as in order after the left, we put the root. So we go array.push root value. Then we loop through the right side of the tree. So root.right. Okay. Now let's execute the function in order root, and then we return the array, which would be the return ordered in order traversal, pretty much. Let's run here. As you can see, it passes. Let's submit. As you can see, this is the fastest time complexity, fastest speed, and the time complexity should be O of n. Yep. As we're only looping through the tree once. And space complexity is O of n, as again we're storing the whole tree. Thanks for watching.